All right, guys, so this is FRQ 2018, number 2. On this one, you can use a calculator, and we will be. They tell us that a particle is moving along the x-axis, and they give us a velocity function on this time interval. So, first of all, since they're giving us the velocity function, if at any time they ask for acceleration, then that's going to be the derivative of the velocity function. And if at any time they ask for the position, then that's going to be found by doing the initial position. So I'll put S for starting position plus the displacement from 0 to whatever time they want. So that's how we'll find those things. Let's go ahead and begin here. They also do give us an initial position here. So there it is. So it's -5. So I guess I can come up here and replace my S with -5 for my starting position. All right, let's begin the problem here. They want us to find the acceleration. As I mentioned, that's the derivative. So I need to find v prime of 3, and then I'll have my answer. That's literally all you guys have to find. You do need to type it into your calculator, though. So you're going to put this here in to your Y1. Then you're going to go back to the home screen and do Math 8 to figure out the derivative at 3. And I'm getting -2.118. And we don't need any units or anything like that. They didn't give us units. They're not asking for units, so we're good to go there. For part B, they want to find the position of the particle, and for that we'll be using this little formula there. So that would be the starting position plus the net change from 0, the starting time, up to the ending time, which is 3. And once again, we'll go ahead and punch that into our calculator. -5 plus the integral, which you can do by doing Math 9. And you go ahead and put your stuff in there. And I'm getting -1.76 would be the position at that point in time. For part C, they want us to find both of these things and then interpret what each of those things are. So let's punch that stuff into our calculator. And for this one, I get 2.844. And for this one, I get 3.737. If you forgot how to get the absolute value on a calculator, it's under Math, and then you scroll over to the right under the NUM category, and it's the first option, abbreviated ABS. But there it is. So now they want us to interpret that. Well, this is displacement, and this is distance. So what we would say is that the displacement from t equals 0 to t equals 3.5 is 2.844. Now, that's enough to get credit, and I think that's good enough. But just to help you guys further understand it, displacement's a fancy word. Remember what that means. Since we're traveling on an x-axis, the particle starts at -5. So after 3.5 seconds go by, the object is now 2.844 spaces to the right of that, which would be about here at 7.84. Well, actually it's to the right, so I can't do the math in my head, but it's 2 spaces to the right would be -3. So it's going to be somewhere like right about here, but it's about 2.844 spaces to the right. It's to the right of it because it's positive. Now, you don't need to include that in your explanation. I think what I wrote down there at the bottom is good enough. But just want you guys to remember displacement is how far the ending position is from the starting position. This number here, on the other hand, that's distance. So this means the particle traveled a distance of 3.737 on the interval t equals 0 to t equals 3.5. So this one doesn't tell us how far it is away from the starting point. This one tells us the total distance it traveled. Okay? So that's the end of part C. Let's go ahead and take a look at part D. Part D tells us that a second particle moves along the x-axis with a position given by this. At what time are the two particles moving with the same velocity? Well, if particle, we'll call this one particle 2. If particle 2 has a position given by this function here, then particle 2's velocity is the derivative of that. Now, I already know what the velocity of my first particle is. It's this. So they want to know, when do they have the same velocity? So, in other words, when does x prime, x sub 2 prime of t equal v of t? So when does this function equal this function? What we're going to do to solve this, you guys, is I'm going to start by finding the derivative of this function, x prime, and then I'm going to graph that derivative and find where it intersects with this function. And where they cross is where they're equal. Okay? So, let's begin here. First of all, the derivative is 2t minus 1. So, the particles have the same velocity when x prime sub 2 of t is equal to v of t. This occurs at t equals, and now I got to find the answer. And like I said, the way I'm going to do that is I'm going to graph this function and this function on the same window. Now, I just want you guys to know what window is useful when you're graphing this. First of all, they tell you the x value. So this, your x minimum and your x maximum, that's for your window. Now, I also found that when I was graphing, some good values for the y's would be -3 and +3. Now, you might be asking, how do I know that? Well, it's because I just graphed it on the standard window, 10 to 10, and it was just not a good view, so I decided to zoom in. But, you know, it's not a huge deal. But basically, you want to adjust your viewing window to this if you want to have a nice picture of what the graphs look like. But anyway, go ahead and graph this function and this function with this window, and then I'll show you what your graph should look like after that. So your graph should be looking something like the following. We have like a little wavy line that looks like that, and then we have a straight line which is looking something like this. So they should be looking like that. The blue one is the original velocity function, and the red one is the new velocity function for the second particle. And we want to know, when do they have the same velocity? Well, their velocities are the same when they intersect. So we need to find where those two functions are intersecting. So how do you do that? You're going to press second, then you're going to choose the Calc button, which is trace also, by the way. And then you're going to choose the option where it says intersect. After that, you're going to scroll your cursor to where they are intersecting, and then you push enter 3 times. And I'm getting 1.571. And there you go. So, there you guys have it. That's how we can find when those velocities are the same. All right, so that does it for that FRQ. We'll move on to the next one later.